as you can see in exercise 405, we're going to compare relative frequency and theoretical probability. Now, you probably realise that you can't always run an experiment in order to get the relative frequency that something might happen. And so we have to work with our theoretical probability to determine or to get an estimate of what might happen in the future in particular situations. Now, we could now introduce another term, that being the expected frequency. Expected frequency. An expected frequency would be our theoretical probability, the probability that an event will occur, times the frequency of an event. Now, the simplest one to understand is with rolling a dice. So we know that when you roll a dice, the probability of getting a 1 in rolling a dice is 1 in 6. If I was to roll the dice 30 times, and that 30 times becomes the frequency, the 1 in 6 is the probability. So my expected frequency for getting a 1 when I roll a dice is the probability of getting the 1, which is 1 in 6, and I'm going to roll the dice 30 times. My expected frequency for 1 in 30 rolls of the dice is 5. I'm expecting that I would get 5 ones out of a total of 30 rolls of the dice. This is all based on my theoretical probability. Well, we could perform an experiment, roll a dice 30 times, and know that there is a possibility that we could get 5 ones. There's a possibility we could get more than 5, or there's a possibility that we could get less than 5. But like I said at the beginning of this video, we're not always able to perform an experiment. If I'm working for an insurance company, I'm not able to perform an experiment and create car accidents. However, based on my theoretical probability understanding, I could make an expectation about what the probability of an accident might be, and then multiply it by the number of cars that I know go through a particular intersection or are on a particular road or in a particular, that are normally housed at a particular suburb. So we're just going to have a look in this exercise at comparing what we expected to happen based on our theoretical probability with what actually did happen in an experiment. Now you can see that I've just answered this. How many 6s would you expect if you rolled the dice 72 times? So the number of 6s I would expect is the probability of an event times the frequency, which is 72 in this case. I would expect to get 12 6s. So you can see here with 30 rolls of the dice, I'm expecting 5. With 72 rolls of the dice, I'm expecting 12. This example now changes the frequency again to 60 rolls of a dice, and the results have been shown. So you can see that a 1 did occur 6 times. Out of 60, 6 times out of 60. The 2 occurred 13 times out of 60. You can see that they're all varying. The 3 occurred 12 times, 4, 8, 5, 9, and 6, 12 times. Now, out of 60 rolls of the dice, we would, in theory, expect to get exactly the same number for the 1, 2, 3, 4, 5, 6 for each of them. And what would that be? What is 1/6 of 60? That is 10 times. Now, there was actually none of them occurred the expected number of times. Some occurred less, some occurred more, less and more. Yeah, so you can see that what happens in an experiment is not always exactly what happens is not what happens necessarily. The reason in our prediction from our theoretical probability, the problem being this sample is not big enough. 60 rolls of the dice, not big enough. If we did 6,000 rolls of the dice, we'd be much more likely to get the expected result using our theoretical probability. So, like I said, this exercise is about comparing the relative frequency, which you learned in the previous exercise, or the experimental probability, these two things are the same, to the theoretical probability. So I'll write up these results and then come back and talk about them. So A asks you to find the relative frequency or experimental probability. Now, I'm not sure if I've suggested that you write that these two terms are the same in your summary and key points, but I think that would be a really good idea. So the relative frequency of rolling a 1 as a fraction, so the relative frequency of the 4 was 8 out of the total 60, and 8 out of 60 is the fraction 2 on 15. Now, 2 on 15, we know it's pretty small, but part 2 actually gets you to convert it to a decimal. Now, if you're unsure, you've got a, let me just drag this over. You can see there actually I've done the 1 on 6 conversion. You've got this button, fraction to decimal, and then I'll go fraction to decimal again. So it's at the decimal or it's at the fraction. So it's just simply pressing this fraction to decimal, decimal to fraction. If I was to change that, delete and change it to a 3 and press equals, and then do fraction to decimal, or it's a third, or it's 0.3. Let me now show you 2 in 15. Two in 15. I press equals, it's a fraction, but to the decimal, it's, as you can see, the 1.3 repeating, and we write that as 0.13 and a dot over the 3. Okay, so we've now got a decimal, 0.13. Part B asks you to now find the theoretical probability. Well, we know the probability of getting a 4, we would say in theory, because there's only one 4 on the dice out of 6 sides or 6 results, and that is the fraction 0.1666 repeating, which when you press your fraction to decimal button, you'll get 0.16. And you put a dot over the 6 to indicate the 6 is repeating. Then C says, are they similar? Yes, they are definitely similar. 0.13, 0.16, they're very similar, very similar. I think that concludes the exercise or the examples, and you should be right to do 405.